This is the Smart Buildings Academy podcast with Phil Zito, episode 213. Hey folks, Phil Zito here, and welcome to episode 213 of the Smart Buildings Academy podcast. And in this episode, we are going to be talking about creating your own pandemic mode. We're going to go through what a pandemic mode is. We're going to talk about the general purpose of it. We're going to talk about how you implement the pandemic mode in your control system. We're also going to dive through some of the resources that are available on the ASHRAE website. They have a really good coronavirus website page that goes through a lot of really good details. So we're going to be talking through that as well. So with that being said, all resources that are mentioned in this episode can be found at podcasts.smartbuildingsacademy.com/213. Once again, that is podcasts.smartbuildingsacademy.com/213. And I want to be clear, that is podcast, not podcasts. So podcast.smartbuildingsacademy.com/213. All right, so let's dive in. So what is pandemic mode? When you are thinking about reoccupying a building, depending on what kind of surveys you're reading, anywhere from 60 to 30% or 30 to 60% of people say that the condition of the building is directly impacting their decision of whether they want to reoccupy a building or not. And although I haven't seen this happening yet, I'm sure there is litigation coming in the form of liability for people who supposedly got sick due to the conditions within a building. I haven't seen it. I haven't read about it in the news. You think it would be all over the news if it was happening, but I would not be surprised to see class action lawsuits of some sort saying, hey, did this cause this? I would not be surprised. So one way you can potentially work around these issues is by implementing a pandemic mode. Now, I do want to caution before we go any further, I'm not a lawyer. This is not legal advice. I am just someone who is providing their interpretation of the recommendations that are available on the ASHRAE site based on my own personal experience. Please go and consult a professional before implementing any of these strategies. With that being said, let's dive in. So what is this pandemic mode? What is its general purpose? Well, pandemic mode is basically a mode that says, hey, let's go through the building, let's flush out the building. It could be anything from flushing the building with fresh air to simply going in, increasing air changes, to changing filtering, to monitoring. The problem with pandemic mode, while it's very sexy from a marketing perspective, the actual definition of pandemic mode varies based on who you're talking to. If you're talking to some organizations, they will simply tell you that it is more monitoring and more control, which coincidentally ties to your need to upgrade a building automation system, which they will happily provide you, so you can kind of see the marketing in that aspect. And then on the flip side, you have what, in my opinion, is best in class, which is the general recommendations by ASHRAE around what they determine pandemic mode to be. And essentially from their definition, it's more outside air, increased air changes, more sensing, and control of temperature and humidity to kind of tighter tolerances, increasing the humidity as much as you can. That way you can increase the moisture density in the air, thus allow less of the viral particulates to be floating around in the airstream and having that moisture kind of capturing them and forcing them to the ground. That essentially is what ASHRAE is saying in their documentation. Now, if you go to go to podcast.smartbuildingsacademy.com/213. You scroll down to the resources. You will see the document in which I'm spending most of the time kind of providing my interpretation of. The document, while very good, assumes a lot of knowledge, and I'm going to try to fill in the gaps as we move through that. So one of the first things that I've really been hammering on this for probably the better part of 2 years now, of just the need to audit your building systems, the need to actually know what's within a building. And for those of you who are maybe struggling, and I'm talking to the contractors right now, and you're maybe struggling like, man, our capital projects are drying up. What can we possibly do to be keeping our guys and gals busy? One of the things I would highly recommend that would actually be beneficial, I do not recommend things unless I really do think they'd be beneficial, but something that would be beneficial to your customers would be offering a remote service where your actual technicians process the customer's documentation, both by looking through their MEP sets and their O&Ms and looking at their control system remotely, and then provide essentially hey, this is what you have. This is what you need to upgrade in order to better monitor and control your environmental conditions, your IAQ, in order to provide the safest environment to your tenants. I mean, honestly, I think you could sell this like hotcakes, and it would be valuable at the same time. There are so many customers out there who are really struggling to get a grasp of what's in their building or buildings, and then what actions do they take to update the systems in those buildings. That is something that you'd be surprised how much consultants get paid to come in and do that. And why not you? I mean, if you got people sitting on the bench instead of letting them go, why not you? Why not going and doing that? Now, from a customer's perspective, I know some of you are listening to this and you're building operators and you're like, but Phil, what about me? Well, quite simply, you can do this as well. So how do you audit your system? We've went through this in previous episodes. I'd like to think it's like episode 207, 206. I'll link to it in the show notes at podcast.smartbuildingsacademy.com/213. But I went through exactly how to do this. So I'm going to go through it at a high level and know that you can refer to that episode and kind of understand. Okay, so you've got to go through, collect your documentation. Once you've collected your documents, you got to validate your documentation. Documentation being your MEP sets, your O&M manuals, your submittals, etc. Once you have an idea of what you have, then you need to go and figure out what do you need to mediate in order, or remediate, in order to basically bring your system up to speed. Usually this is sensor density, grabbing humidity sensors, getting control of economizers. Those are kind of the highlights of the things that you're going to be going and affecting in order to make your building kind of pandemic ready. I can't even say that with a straight face. It's freaking ridiculous. But in all seriousness, that's what you need to do in order to make your system have better IAQ control, which is really what this is about, right? I don't like doing the kind of snake oil salesman, hey, pandemic this, pandemic that. I just, at the end of the day, we're trying to get better control of our indoor air quality. That's really what this all comes down to. Everything else is driven by that. And if you understand that, we're trying to control indoor air quality, that will be what guides your decisions. Do you need analytics to do indoor air quality? Probably not. Would it help from a reporting perspective? Yeah, but do you need it? No. Another thing, do you need to upgrade your entire building automation system? Probably not. Not really. I mean, yeah, it's great to have a single software suite that has all this stuff built into it. But the reality is, adding a couple sensors and making some programmatic changes to your field controllers, you could do most of what ASHRAE is requiring. I mean, at the end of the day, they're requiring increased air control, increased filtration, which means you have to really up your differential pressure settings at your, get the hiccups, at your air handling units to account for that pressure drop across, if you're using MERV 13 now instead of like some lower grade bag filters, you now have to go and account for that pressure drop. So these are all kind of changes that you have to make. Once you've done that, once you've closed these gaps, then you implement these programmatic changes and then you monitor the changes. So let's talk through kind of what are these changes. I feel like everyone talks about pandemic mode on LinkedIn and they talk about it, but then they don't go through what it actually is. So if you're going through this document that I have listed at podcast.smartbuildingsacademy.com/213, first thing you'll notice is that ASHRAE, surprise, surprise, says review your current operational practices. I mean, right? We've talked through that quite a bit. You need to understand what you have, what your sequence of operations are, what your set points are, what your schedules are. Those specific things are going to be very important. Sequence of operations are going to be important because we're going to be modifying those. Set points are going to be important because we're going to be modifying those. And schedules are important because guess what? We're going to be modifying those as well. And the reason why we want to know all of these is because eventually coronavirus is going to be over and we are going to roll back to more energy efficient sequences, set points, and schedules. Because let's be real, running 100% outdoor air, 24/7 fan circulation, increased air changes is not energy efficient. It's not efficient on the wear and tear of your equipment. So that's the reality of wanting to run a more kind of indoor air quality friendly building. You at the same time are going to have, a increase in energy expenditures. You're going to have improvements that you're going to have to make to your equipment, etc. Now, there is stuff that talking about in environment monitoring around monitoring people counting, things like that. The practicality, having used people counting technologies in the past, short of badging in and badging out and making sure that every possible access point in the building is secure. Short of that, badging in and badging out really being the only really truly effective way. I know I'm going to get people who are going to email me that are going to say their passive infrared sensors or their analytics system can do very accurate people counting. And you know what? You're probably right. They probably can. Can they do it at a cost-effective point that makes sense for a capital or operational budget? Probably not. But most buildings have some form of access control, and you can implement that in such a way that you can get some decent occupant counting. But at the end of the day, I personally, if I'm in your shoes, either as a contractor or as an owner, I am going to focus primarily on the IAQ, increasing my outdoor airflow, increasing my air change rates, increasing my temperature, increasing my humidity, getting good humidity sensing, making sure my temperature sensing is accurate. I'm going to focus on those things along with social distancing more than I'm going to focus on people counting. My bang for my buck is on the things I just mentioned, not really on analytics, not really on people counting. I know that's going to upset some folks. That's going to probably upset a lot of manufacturers who are going to send me emails and say, Phil, our stuff can do this, 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 and this. And once again, I want to be clear. I completely agree with you that your stuff can do that. I do not think it is necessarily the best use of capital dollars for owners who are already facing budgetary constraints due to loss of revenue. All right. I want to be clear on that. So the ASHRAE document says, develop a pandemic preparedness plan, right? And it talks about what the plan is, right? Reducing the spread of infection, maintaining HVAC systems in safe and healthy conditions, minimizing impact, all making people wear masks and stuff like that. It's fairly obvious stuff, screening and monitoring. So we don't need to spend a ton of time talking about that. Next up, though, it says review indoor and outdoor environment and review the space types. I think these are two things that largely get missed, right? They largely get missed from the perspective of, hey, what can we do? What can we change? So first thing they mention is maintain dry bulb temperatures within the comfort ranges indicated in ASHRAE 55. If you've never read ASHRAE 55, you really should be familiar with it, regardless of whether we're in coronavirus or whatever virus comes along later in life. you should still understand ASHRAE 55, ASHRAE 62, and ASHRAE 90. These are like things that I am shocked so many people in our industry don't understand, yet they drive so much of the engineering and design of our facilities. I run into so many technicians who don't understand ASHRAE 62.1, but yet it drives minimum outdoor air damper position. It drives our CO2 control of our economizer. ASHRAE 55 drives set point selection, yet people don't understand what the thermal comfort corridor is, and they don't understand how to read a psych chart. ASHRAE 90 drives a lot of equipment selection, yet people don't understand what it is. Really go and understand those. That would be very beneficial use of your time. If you're sitting there and you're not busy because, you don't have work or whatever, people aren't in your building, taking an hour to read these 3 standards, which I'll link to at smartbuildingsacademy.com. Man, that is a mouthful, right? I'm telling you. podcast.smartbuildingsacademy.com/213. I'll link to those 3 standards. They're very beneficial. So they break it out in cold climates and warm climates. So in cold climates, which most of us are going to be entering in the very near future, they talk about no humidification, right? If the system doesn't have that, you may not be able to achieve the minimum humidity. So that's something we need to start considering, humidity being one of the greatest factors besides for filtration and air change rate in reducing the viral spread because of that moisture content that I talked about earlier in the episode. So we really want to go check our Nortec humidifiers, make sure they're actually working, make sure that they're all set up, because we all know how we go through and we put in these humidifiers and then we never use them because they're a pain in the butt to control and they're a pain in the butt to maintain. And the downstream effects of moisture in our air systems is also a pain in the butt. So we tend to turn them off. Well, it's time to turn them back on and make sure they actually work. It also talks about checking your indoor assemblies for condensation, because of this little thing called dew point. And as we're introducing more moisture content into our air streams, we are going to kind of raise the moisture in our air. And if we are in a cold area, we could potentially subcool and cause condensate to build up. We've all seen it. Condensate building up on stuff is not good. Moisture in a building is not good. We need to be aware of that. And, there's ways to deal with that through different control sequences. And then, making sure that we're not excessively producing humidity within our building. Now, in the hot climates, the warm climates, we run into the opposite. We run into, if we don't have a dedicated outdoor air system or a DOAS, then we tend to be pulling in all this moist hot air into our outdoor air dampers to maintain that kind of 100% outdoor air that we're striving for. And we're introducing a bunch of moisture. So in cold climates, we have potential dew point issues and condensate issues, and we have potential lack of humidification issues depending on where you're at, whether it's a cold moist or a dry cold, right? Whether it's a moist cold or dry cold. In the hot climates, right, we have kind of the same thing, whether we're a dry hot like Arizona or we're a wet hot like Louisiana will drive how we are going to control things. We may be looking at decascent wheels. We may be looking at preconditioning with DOAS units. There's a variety of systems. Obviously, some of these things are going to have to be in-field modifications, retrofits, things like that. Once again, we have to make sure that we are maintaining moisture. Now it talks about space types. And space types, how do they affect us? Now, there's a lot of operational strategies around space types, but from a controlling perspective, we really want to make sure that we are not driving the control of our conference rooms or other spaces based on occupancy sensors. We really want to drive them based on 24/7 occupancy. We want to keep air circulating in those spaces. We want to make sure that our spaces have adequate air ventilation, we want to drive towards positive pressurization as much as possible, unless we're like in a hospital scenario where we need negative pressure rooms. But we want to drive positive pressurization. We want to really go and push that air out, right? We want to make sure that we're doing that while at the same time maintaining air changes. Now, I wanted you to understand what I was just saying there, because we can have low air changes and positive pressure. How we do that is if we're exhausting less air than we're putting in, we can actually be not really exhausting any air and create a positive pressure scenario. And that's not necessarily good because we're still not taking advantage of filtration. So we want to have high velocities of air, so high air changes, while also maintaining a slightly positive pressurization. Now, that being said, you could argue for negative pressurization as well. There's no real determination on positive or negative pressurization being better than the other, because you could say negative pressurization is good because it keeps all of the air constrained to that space. And so if there's a conference room full of sick people, it's not going to leak out. I will say that in most cases, positive pressurization is going to be better in a non-healthcare environment. In a healthcare environment, obviously, you're going to want more negative pressure situations to suck that air in and keep any infectious air in that space and not from going out into hallways and things like that. So we talk about space types. Next, we move to actually operating and maintaining our HVAC. Now, there are a bunch of documents. ASHRAE has standard 180, which is basically how do you inspect and maintain commercial HVAC. It talks about the common ways of maintaining that. Things we're focused on are increased filter changes, checking of coils, and as we increase our filtering, making sure that nothing's building up on those coils and that they're not being starved at the same time, making sure that our pressure drops are reasonable so that we can actually get the proper airflow through our system so we can condition the spaces. Now, when we move in to actually controlling the systems themselves, we're shifting largely from a occupancy schedule to a 24/7 schedule. The main areas they ask us to focus on are going and operating all of our systems as much as we can, ideally 24/7. So chillers, if needed, boilers if needed, air handling systems, VAV terminal units, etc. They ask for the outdoor air ventilation to be increased as much as the HVAC system can accommodate, and here's the key point, while still maintaining acceptable indoor conditions during occupied hours. That's the real catch. You see a lot of people posting, hey, we should be doing 100% outdoor air all the time. And I myself have been guilty of saying that, when what I actually mean is we should run as much outdoor air as we can while still maintaining the IAQ standards inside the building, specifically the ASHRAE 55 standards. Because at the end of the day, if we're going and we're driving all this outdoor air in, but we're introducing all this moisture buildup and we're creating mildew and damage in the space, we're not doing anyone any favors. So it's kind of this delicate dance and balance. So if you are programming this, if you're developing it, you would have a IAQ and you would be watching that IAQ, right? Zone temp and humidity. You would be watching those two. And then you would be using those to drive outdoor air damper position. So it's almost like CO2 driving outdoor air damper position, but it's actually zone temperature and humidity. And honestly, I will argue in most cases, humidity is going to be the more important one in a very moist climate to watch, because with very dry climates, you can still get amazing deltas across your coil because there's no moisture in the air. And you can really take advantage of kind of evaporating and just taking heat and reducing it and just clean transfers through the coils. I don't know why I said evaporating, because we're not evaporating any moisture when it's actually in very dry air. Anywho, as I was saying, we have that, right? We're looking at zone temp and humidity to drive our outdoor air dampers. It's a little unique, but it's something that works. We're also looking at a flushing sequence. This is where we're basically operating the HVAC system with maximum outdoor air flows for 2 hours before and after occupied times. So that's a minor change that you're going to have to make. You're going to have to be aware that this is going to require your chillers to run outside of their normal occupied hours. And then we're going to talk about, they say, hey, if the building's not occupied or in the flushing mode, we can run it at minimum outdoor air settings, but we still have to be running the units. We still have to be running. So 24/7 minimum outdoor air during unoccupied hours, maximum outdoor air within while still maintaining ASHRAE 55 standards during occupied hours, and a flush before and after occupancy. Now with VAV units, we talk about basically the exact same thing, right? Run your economizer. If there's heating and cooling to temper the air, it can provide the comfort and eliminate recirculation if it can still maintain those ASHRAE 55 standards. And so we've got to be aware of that. Also, it says, hey, in areas like Arizona or wherever where it's, really dry air, we don't want to let our relative humidity be driven below 40%. So we want to prioritize, right, outdoor air over humidity. We want to do that, but at the same time, we want to make sure that we're hitting that 40 to 60% humidity range. So we want to get fresh outdoor air in. That's really important because we're flushing the air out, but we don't want to let the humidity get completely out of whack. That's really important. And another area I want to talk about here is where they talk about raising your discharge air temperature set point on your VAV units to around 60 degrees instead of 55. And also going and making sure that we are letting our VAV terminal units try to satisfy space cooling loads through this increased temperature, at which then is going to basically increase air changes in the space, right? Because exhaust is typically going to remain constant. The supply air is going to vary. And by raising that 60 degrees discharge air, we're now introducing less cold air. So we are going to need more cold air at 60 degrees than we would need at 55. Thus, this is an easy way of increasing air changes from the terminal units. I want to make sure that makes sense, right? Is that if we increase discharge air to 60 degrees, then in order for that air to mix in the space and drive to, let's say, 72, we're going to need more of it, because there's less capacity now in that air to absorb the heat within that space and exhaust that heat. So now we're going to have to increase our discharge airflow from those boxes, which naturally, with a constant exhaust, is going to increase the supply and ultimately the pressure and air changes within those spaces. So that's how all of that kind of comes together. There's a bunch more here, and I think with us running up on the 30-minute time frame, I am going to make this probably a 2-part episode. I'm going to start by going through kind of some sensing. I'm going to go through the control of cooling coils, heat and energy recovery. I'm going to talk through the hydronic systems. I'm going to talk through exhaust, and I'm going to talk through pressure control in the next episode. So at this point in the episode, what I want you to take from here is creating a pandemic mode. The first thing we need to do is we need to know what we have in our buildings, and we do that through data collection. Once we know that, we can start to implement some of these sequences. What are these sequences? We are primarily focused on increasing outdoor airflow because we want fresh air while maintaining those ASHRAE 55 standards of temperature and humidity. Ideally, we want to keep humidity high, more towards that 60% range. More moisture in the air that we can have while keeping people comfortable is going to basically lessen the density of the viral load within a building. So that's good for us to have moisture. So those are kind of our strategies initially that we're going to focus on. In this episode, we went through basic VAV changes. We talked about scheduling changes. We talked about building flush scenarios. We talked about outdoor air and outdoor air control. And like I said, in the next episode, we're going to go and look at the coils. We're going to look at pressurization. We're going to look at exhaust, and we're going to talk about any potential changes and sensing that we may be making. I know this was more of a kind of technical episode, so by all means, please reach out to us. Feel free to post in the discussions, and if you're watching this on YouTube, post in the comments. I'd love to answer any questions for you. Thanks a ton for listening to this episode, and I look forward to talking to you in part 2 of this episode next week. Thanks a ton, and take care.